Okay, so something you need to be able to do is make a comparison between power ratings and energy values. So I'm just going to use this page from your revision guide as a way of talking through this. So to start with power ratings, we've already, of course, calculated energy using the energy equals power multiplied by time equation. And if you think about that, it means if you know how much energy is used and how much time it's been used for, that will help you calculate the power rating of an appliance. So the example on here, a power drill. 500 watts power means that that drill uses 500 joules of energy for every second that it's running or being used. So that's what a power rating means. Definition-wise, if you wanted a word definition, power is the rate of work done or energy transferred. And why that's quite a handy way of remembering it is, when something is rate of, it just means it's how much every second or every minute or every hour. It means per unit time. So what we have here is power is the rate of energy transferred. In other words, it's how much energy in joules is transferred every second, energy per second. And that's where the equation comes from. Power is the amount of energy transferred divided by how long you do it for, and that's where you get the power is energy divided by time, or if you rearrange that, energy is power multiplied by time, and that's the link there. This goes into a bit more detail and does an example, so I'll just talk you through a couple of those. So obviously, higher power means it's going to use more energy in the same amount of time. So if you have a low power TV and a high power TV on for the same amount of time, the high power TV will use more energy in that time, let's say it was an hour, whereas the low power TV will use less energy in the same amount of time. So this is actually just using those equations again. So as you can see, how much energy is transferred by a 1.5 kilowatt electric heater compared to a 4 kilowatt electric heater if they're both left on for 1.5 hours. So it's just back to what we used before. Energy is power multiplied by time. So energy transferred is 1.5 kilowatts multiplied by 1.5 hours. That's 2.25 kilowatt hours. It's just the same equations you used last time. The 4 kilowatt heater, so it's 4 kilowatts is the power multiplied by the 1.5 hours time equals 6 kilowatt hours. And as you can see, you can now compare the two very easily. Then, less obvious link, but food also, of course, the whole point of eating food is to contain or get energy, obviously nutrients and things as well. So, energy in food is measured in kilojoules. Remember, 1 kilojoule is 1,000 joules. So 1 kilojoule is 1,000 joules. Little note here, sometimes they put kcals on there or calories. It's just another unit to measure energy, and we don't have to worry about calculating those. And so here, if we compare the two, so a chocolate, gooey chocolate pudding with ice cream per 100 grams. So it's important when you're comparing that you're looking at comparing it per the same amount. Otherwise, it's like comparing eating a whole cake to a muffin. It's not really a fair comparison. So the gooey chocolate pudding has 1,500 kilojoules for every 100 grams you eat, whereas the nutritious fruit salad only has 150 kilojoules of energy in it for every 100 grams that you eat. Obviously, in terms of diet and things, you have to also look at other things like the fats, the sort of fats, the kind of sugars and so on. But for our purposes, we're just looking at the amount of energy in the food. So that's really all there is to it when it comes to comparing energy values. So there's a couple of exercises for you to do attached to the task, but all of this just builds on what you've done in the previous couple of lessons.